This is project 1.2, the Joule thief. And here's the finished PCB. This 0.7 volt battery is being used to power this 2.8 volt LED. And the key to this entire circuit are these inductors. So to understand what's happening here, let's take a look at our prototype. Here, the inductors are replaced with our toroid ferrite core. The prototype also has a 1 kΩ resistor, one 30 nanophore transistor, one slide switch, one LED, and of course our power supply. So what happens is current flows through coil 1 over here and into the base pin of the transistor. And this turns on the transistor, which allows larger current to flow from this, let's call this coil 2 over here, into the collector and towards ground. This current creates a magnetic field in the toroid. And since coil 1 and 2 are wound on the same core, this field links both of the two coils. And this changing magnetic field induces a voltage in coil 1 due to Faraday's law. That boosts the base current. So now even more current flows into the base and the transistor turns on even more. This is a positive feedback loop. So the more current, the stronger the field, the more voltage is induced, and so on and so forth. And eventually, the magnetic core becomes saturated and it can't store any more magnetic field. And at this point, the change in the magnetic field stops, the induced voltage will drop, the drive to the base pin of the transistor disappears, and the transistor will turn off. This causes the entire field to collapse in an opposite effect as when it was building up. And this sudden change in magnetic field induces a big voltage spike in coil 2 over here, much higher than the original power supply due to Faraday's law, which means a rapidly changing magnetic field induces a voltage spike. This spike is what powers the LED over here. So the LED isn't always on, it's just oscillating on and off so fast that we can't see it. And then of course, when the transistor turns off and everything goes down, the current will eventually begin flowing again, and this cycle starts over and over again. So let's take a peek at our PCB again. Instead of our toroid ferrite core, we have our 100 microhenry inductors, and then we also have our 1 kΩ resistor, 30 nanophore transistor, a switch, slide switch, 2.8 volt LED, and our battery. So in conclusion, power isn't being created, instead it's being stored and released rapidly.